It's a very good question. Probably the temperature interval is just like the delta temperature. So if someone's 10 degrees, the other one's 20 degrees, and like absolute temperature, then it's 10 degrees maybe. I don't know though.
How Keen is Your Rank? The full story is an episode of the Degrees of Freedom Project, videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description. This episode explains how to convert temperatures and temperature intervals among Kelvin, degrees Rankine, degrees Fahrenheit, and degrees Celsius. Another video, Is Furlongs per Fortnight a Thing?, explains how to convert a measured or calculated quantity from one set of units to another for most everything except for temperatures. A third video, The Most Annoying Equation Conversion, explains how to convert an equation as opposed to a calculated or measured quantity from one set of units to another. Again, the links are in the description.
What are the common units of temperature used in chemical and thermal processing?
Centigrade and Fahrenheit.
I'd probably say Kelvin is the most common one for like chemistry, and then Celsius, and Fahrenheit is the imperial one.
Over the years, there have been a lot of temperature scales. Here are the 4 that are currently in use: Kelvin, Celsius, Fahrenheit, and Rankine, with some common temperatures among them labeled. For example, this tick mark indicates the boiling point of water, and this tick mark indicates the freezing point of water. The original Celsius scale was upside down. Water boiled at 0 degrees Celsius and froze at 100 degrees Celsius. Let's take a moment to fix the scale to the current version.
What 2 common temperature scales are absolute scales starting at absolute 0?
Centigrade. I don't know another one.
Oh, I know Kelvin is one. I do not know what the other one is.
Kelvin and Rankine are both absolute scales, starting at the same absolute 0, at which all particle motion stops. We'll cover the ideal gas law in a later video, but for now, you need to know that PV equals nRT, or the pressure times the total volume equals the number of moles times the gas constant times the temperature. This formula only works if your temperature scale starts at absolute 0. Kelvin is used in SI units, and Rankine is used in American engineering units. For example, if you're measuring temperatures in degrees Fahrenheit and you want to use the ideal gas law, convert the temperatures to Rankine. Think of Kelvin as the Celsius scale shifted to start at absolute 0, and Rankine as the Fahrenheit scale shifted to start at absolute 0. Rankine and Fahrenheit share the same relationship as Kelvin and Celsius. Since they both start at absolute 0, you can convert between Kelvin and Rankine by simple multiplication. For example, 400 Kelvin is equivalent to 720 degrees Rankine. If we divide both sides by 400 Kelvin, we'll get 9/5 degrees Rankine per Kelvin is equal to 1. Conversions among other combinations requires an addition or subtraction as well to account for the offset in the 0 point.
Yeah, what is the difference between the temperature of an object and then temperature interval, meaning the difference between the temperature of 2 objects?
One's a comparison and one's an absolute value.
It's a very good question. Probably the temperature interval is just like the delta temperature. So if someone's 10 degrees, the other one's 20 degrees, and like absolute temperature, then it's 10 degrees maybe. I don't know though.
It's important to distinguish between a temperature and a temperature interval. A temperature is the single temperature of an object, and a temperature interval is the difference between 2 temperatures. If you are using a temperature sensor, such as a thermometer, to measure something, you are measuring a temperature. For example, the freezing and boiling points of water at atmospheric pressure are both fixed temperatures. They are 32 degrees Fahrenheit and 212 degrees Fahrenheit, respectively. If you are measuring the difference between two temperatures, you are measuring a temperature interval. For example, the difference between the freezing and boiling points of water is 180 degrees Fahrenheit. As can be demonstrated, it is also 180 degrees Rankine. Temperatures, as opposed to temperature intervals, have to be converted from one scale to another by the full conversion equations, often with addition or subtraction instead of just multiplication. You can find the conversion formula between two scales by knowing the same two temperatures in both scales. For example, water freezes at 32 degrees Fahrenheit and 0 degrees Celsius, and boils at 212 degrees Fahrenheit and 100 degrees Celsius. Set up two linear equations with two unknowns, the slope and the intercept, so 32 degrees Fahrenheit equals m times 0 degrees Celsius plus b, which gives b equals 32. Then 212 degrees Fahrenheit equals m times 100 degrees Celsius plus b equals 100 degrees Celsius plus 32. Solving for m gives m equals 9/5. Converting temperature intervals requires simple multiplication or division without any addition or subtraction. It is important to determine which is which. Let's first go through the equation for converting one temperature to another, beginning with Celsius. They were all derived like the example above. To convert from degrees Celsius to degrees Fahrenheit, multiply by 9/5 and then add 32. To convert from degrees Celsius to Kelvin, add 273.15. To convert from degrees Celsius to degrees Rankine, first convert to Kelvin and then to Rankine, or multiply by 9/5 and then add 491.67. To convert from degrees Fahrenheit to degrees Celsius, subtract 32 and then multiply by 5/9. To convert from degrees Fahrenheit to Kelvin, first convert to Celsius and then to Kelvin. There is a formula for single addition, but it requires you to memorize 255.37. Not worth it in our opinion. To convert from Fahrenheit to Rankine, add 459.67. To convert from Kelvin to degrees Fahrenheit, either convert to Celsius and then to Fahrenheit, or multiply by 9/5 and then subtract 459.67. To convert from Kelvin to degrees Celsius, subtract 273.15. To convert from Kelvin to degrees Rankine, multiply by 9/5. To convert from degrees Rankine to degrees Fahrenheit, subtract 459.67. To convert from degrees Rankine to Kelvin, multiply by 5/9. To convert from degrees Rankine to degrees Celsius, either convert to Kelvin and then degrees Celsius, easiest, or subtract 491.67 and then multiply it by 5/9. A table with the temperature conversions all on one page is linked on the website. To convert temperature intervals rather than temperatures from one scale to another, multiply by 1 in the case of degrees Celsius to Kelvin, Kelvin to degrees Celsius, degrees Rankine to degrees Fahrenheit, and degrees Fahrenheit to degrees Rankine. Multiply by 5/9 in the case of degrees Rankine to Kelvin, degrees Fahrenheit to Kelvin, degrees Rankine to degrees Celsius, and degrees Fahrenheit to degrees Celsius. Multiply by 9/5 in the case of Kelvin to degrees Fahrenheit, degrees Celsius to degrees Fahrenheit, Kelvin to degrees Rankine, and degrees Celsius to degrees Rankine. Now for some examples. These examples will be easier if you pull up the conversion sheet from the website. What is 5 degrees Celsius in Kelvin, degrees Fahrenheit, and degrees Rankine? Remember, we are first starting with degrees Celsius and want to get to Kelvin, so we must add 273.15. Meaning that 5 degrees Celsius is equal to 278.15 Kelvin. Next, we are starting with Celsius and want to get to Fahrenheit, so we must multiply by 9/5 and add 32. Meaning that 5 degrees Celsius is equal to 41 degrees Fahrenheit. Finally, we are starting with Celsius and want to get to Rankine. Remember, when converting from Celsius to Rankine, we first prefer to convert to Kelvin and then Rankine. We can use what we got from our first conversion, 278.15 Kelvin, and then convert to Rankine by multiplying by 9/5. Which gives us 500.67 degrees Rankine. Now for one more example. The heat capacity of an object is the amount of heat energy required to raise the temperature of a unit mass or unit mole by 1 degree in the temperature unit of interest. We have a formula for the heat capacity of liquid acetone in units of kilojoules per mole degree C, with the temperature in the formula in degrees C. We want the formula for the heat capacity, C sub P, in kilojoules per mole Kelvin with the temperature in Kelvin, kilojoules per mole degree Rankine with the temperature in degrees Rankine, and kilojoules per mole degrees Fahrenheit with the temperature in degrees Fahrenheit. Note that because the temperature unit appears in two places, the T and the heat capacity, we have to convert in both places. The full procedure for converting an equation with dimensions is discussed at length in the Most Annoying Equation Conversion video. If this example seems confusing, go and watch that video and then come back. We start by looking for temperatures and temperature intervals because they need to be converted differently. The left side of the equation, the heat capacity, C sub P, is used only with a change in temperature or a temperature interval, in other words, per degree C. So we must convert it with the temperature interval formula. The right side uses the actual temperature, T, so we must convert it with a temperature formula. First, let's convert from Celsius to Kelvin. Okay. As explained in the Most Annoying Equation Conversion video, we convert the heat capacity, C sub P, in kilojoules per mole Kelvin to kilojoules per mole degree C as a temperature interval by multiplying by 1 Kelvin per degree C. We convert T in Kelvin to T in degrees C by subtracting 273.15, and we plug in, getting this equation. We then simplify and get this equation. Now let's convert from Celsius to Rankine. We convert the heat capacity, C sub P, in kilojoules per mole degree Rankine to kilojoules per mole degree C as a temperature interval by multiplying by 9 degrees Rankine per 5 degrees C. We convert T in Rankine to degrees C by subtracting 491.67 and then multiplying by 5/9, and we plug in, getting this equation. We then simplify and get this equation. Now, let's convert from Celsius to Fahrenheit. We convert the C sub P in kilojoules per mole degrees Fahrenheit to kilojoules per mole degrees C as a temperature interval by multiplying by 9 degrees Fahrenheit for 5 degrees C. We convert T in degrees Fahrenheit to T in degrees C by subtracting 32 and then multiplying by 5/9. We plug in and get this equation. We then simplify and get this equation. Obviously, it's probably best to express the coefficients in scientific notation. I left them as is in decimal fractions to make the comparison easier. Take a moment to double-check the conversions by plugging in some temperatures, such as 15 degrees C, which is 59 degrees Fahrenheit, 288.15 Kelvin, and 518.67 degrees Rankine into each equation in turn. The degree C and the Kelvin equations should give the same values of heat capacity, C sub P. The degrees Rankine and the degrees Fahrenheit equation should give the same values of C sub P. And the degrees Rankine or degrees Fahrenheit value should be 5/9 of the degree Celsius or Kelvin value. Why is it 5/9 and not 9/5 or 1? The takeaways from this video are: 1. There are 4 types of common temperature scales: Kelvin, Rankine, Fahrenheit, and Celsius. 2. The conversions of temperatures are different from the conversion of temperature intervals. 3. Each of the temperatures can be converted from one to another using multiplication and often addition and subtraction. Conversion between Rankine and Kelvin only requires multiplication. 4. All of the temperature interval conversions require multiplication by 9/5, 5/9, or 1. Thanks for watching. This video was brought to you by the DOFPro team.